Hi, good day, everyone. Part of what I promised to record is steroid and eicosanoids. We have recorded eicosanoids and we have recorded eicosanoid and lipoproteins. And the recording will be shared with you. And for eicosanoids, like we have also started discussing while talking about the functions of lipids, we said some of these lipids are known to have some bioactivity in the biological system. They trigger some, they can induce or they can inhibit quite a number of biological processes. And we say this type of lipids are called signaling molecules. They can be an endocrine hormones and they can be an exocrine hormone. So we talked about steroids, which form part of the endocrine hormones. In the case of eicosanoids, basically eicosanoids form part of these exocrine hormones, and we explained the difference between endocrine and exocrine hormones. So they are basically made up of polyunsaturated fatty acids, which serves as the lipid messengers. You have a polyunsaturated fatty acids that undergo some oxidation reaction to form a compound that can serve some biological activity. Usually, these polyunsaturated fatty acids or the precursor of the formation or in the formation of eicosanoid is usually a 20 carbon fatty acid called arachidonic acid. That is why the eicosanoid, the word eicosanoid from the Greek word, means 20. So it's derived from the 20 carbon amino acid called arachidonic acid. So eicosanoid act as a local hormone, the exocrine hormone, to stimulate adjacent cells. So they are produced very closely to where they exert their own effects. And usually, these hormones are produced, or the messenger, chemical messengers, they are produced when their actions is needed, unlike in the case of endocrine hormones, where they are produced and then stored in a particular gland. Whenever they are needed, then they are released. But these ones, when they are needed, they are produced. And once they are produced, then they are released. And where they are released, they are acting very closer to where they are released. So they are released and they act where they are released. This is basically what are eicosanoids, chemical messengers. But by classifications, they are classified into two. We have a prostanoid and we have a linear eicosanoids. And this classification is on the basis of formation of a ring. The basic structure in prostanoids, you can see the structure of the 20 carbon arachidonic acid, 20 carbon arachidonic acid. But in the structure of 20 carbon arachidonic acid, there is no this pentacyclic head that we can see in prostanoic, general prostanoic acid. So what is distinct in prostanoid is this ring structure, the pentacyclic ring structure. Example of the compounds that fall under prostanoids are prostaglandins, thromboxanes, prostacyclins. These compounds were known to exhibit quite a number of biological activity, most especially prostaglandins that are well known to be involved in inflammation activities. Of course, the inflammation process, after inflammation process or inflammatory signals, we know that they are also involved in contraction and relaxation, most especially on bronchial models. That is why quite a number of the asthma drugs they are targeting actually this production of prostaglandins. So they are also involved in contraction and relaxation of uterus. And that is why also some of the therapeutics aimed for abortions were actually targeted to the production of these prostaglandins. So they are also involved in dilation of blood vessels and thereby lowering the blood pressure. So you can also have some drugs also targeting blood pressure, or sorry, drugs for blood pressure or for controlling blood pressure, targeting the production of this prostaglandins. So basically, these prostaglandins, thromboxans, and prostacyclins are known to play a very important role, especially in the bioactivity. The prostaglandins were classified into quite a number of them. Some of them were designated as PG, as plus prostaglandin E, prostaglandin D, E, so even among them, they have some subdivisions depending on their functions. The other ones are called linear eicosanoids. They are also very important in signaling process. The leukotrienes, lipoxins, hydroeicosanoids, acids. These were first obtained from leukocytes, and their structure contains the 3-carbon double bond in conjugation. So it does not have this ring, circular ring, as we have seen in the case of prostanoids. So we can see some structures here of the eicosanoids. We can see prostaglandin E. Like I said, they have some subdivisions. We can see this one is prostaglandin E2. And of course, we can see the cyclic structure